Hey guys, welcome to AlgoYogi, and today we will be solving maximum depth of a binary tree. So let's go to the problem. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the furthest leaf node. Now, depth is different than height. So if you have already solved height, you must have found out if so height is about counting the edges from the root to the leaf. However, in depth, it's about counting the number of nodes from the root to the leaf. So let's see how I'll be solving it. Let me switch the view to our Here, if you see, the answer for this binary tree is 3. And the reason it's 3 is it basically calculated depth for all the paths to the leaf, and then it found the maximum. So if you see, this is one path, this is another path, and this is another path. And the number of nodes in this path is basically 2. Here it's 3, here it's 3. And the maximum is 3. So it returned the answer. Now if we want to find out what's the depth of just one node, that's 1. In terms of height, it would have been 0. It would have been 0 because that's calculating the number of edges, and there is no edge going down from here. But if there is an empty tree, then the depth is 0 and height is -1. I mean, there is nothing like -1, but for the sake of simplicity, we just say it's -1 when we solve height problem. But here, how are we going to find out? We're going to keep a max depth variable, and initially it will be 0. Now for an empty tree, if the root is empty, then it's 0. If root is none, I meant. Now when we traverse a binary tree, so we'll basically call our function on root, and this root, it will be a recursive function, so it's going to ask the left subtree, bro, this node, what is your depth? This will try to ask the left and right, but there is nothing down there, so they will return like 0. And this will say, because I am a good node, I'm like a proper node, so I will return 1. I will return 1 from this side. Then this is getting 1 from this side, but it's not done yet because it needs to ask the right side also. And then it will add itself and return the answer, the maximum from both sides, adding itself. Then it will ask this node, and this node will be like, let me just go down and ask my kids. And it's going to ask its kids. It's going to ask 15, what's your depth? It will say, I have nothing down there, so it will just return 1, and this will just return 1. Now it will see what's the maximum from 1, 1. Doesn't matter. They're both equal. So it will say, Daddy, I am I have 2 child, and both of them's depth is sorry about that. And the depth, both of them has just 1, and my depth is 1, so it's 2. Now this will, the root node will be, okay, I'm getting 2 from this side, the right side, and 1 from left, and my depth is 1, so I will return 1 plus 2, 3. So it will get the maximum from here. And this, we'll just keep it as a variable, like, we don't have to keep it. We can just return, once we come out of the, I'll show you in the code. Let me just show you in the code. It's really simple. I'm sure this was quite simple to understand. Let's go back to our coding screen. Focus it here and then write the solution. Okay, I like to just have an inner function. So that will be find max depth, just to make it different from the parent function. Now it will take the root, and what it will do, have a base condition. If root is none, then we return 0. That's what we talked about. It would if it had been the height question, we will return -1. Okay, and so that it becomes easier for us here when we find the left depth, or why left depth, left max depth we should call it, you know, and that will be just calling our function find max depth on the left root dot left subtree, and same way we will calculate the right max depth. It's gonna ask its kids, the left kid and the right kid. I was like, babies, please return your depth, do the work for me. That's what makes the recursion beautiful. It's like if the base condition is right and you are asking these sub problems to solve themselves using the same function, and you think it's at the lowest level when the root is 0, the logic is happening right, then they should return, on the main tree, it should return the answer. So now, okay, the reason I'm adding 1 here is so that the root itself is added, that node, because it only came down here when the root had some value. It was a proper root, it was a tree, then it's going to add itself, and then here we will return, or I could have added 1 in the answer here as well. So you know what, I think that will be better. How? So that we're not adding to both left and right. So max would be maximum from left and maximum from right side depth, and then you add the root's value because it was a proper root and it was a proper node. So I'm getting from left, it could be returning 0, right? Because what if I was calling it on left, I only have one root, left and right they're both none. I'm calling, however, I'm gonna call those because unless it's none, the value of the root, I will process those. So when I call them on none, they will return 0. So 0 from here, 0 from here. However, because it was a proper node that made the call, so we'll add 1 to it. Okay, so now, and let's just return our find max depth on our root. So I think this is a clear solution, very easy to understand. Simply going to the left, asking its depth, going to the right, asking its depth, and then returning the max from left and right plus adding that root node itself value, which is 1, the depth of proper root. Now let's try to run it. It's find, okay, too soon. Just shut up, I'm not subscribing to you guys, I'm not paying money. Okay, let's honestly, education is free, or it should be free. I don't know why they're capitalizing on teaching. Okay, this is done. Let's go back to our AlgoYogi. Just like AlgoYogi is free to track the problems. So please make use of it and mark our maximum depth of binary tree done. But before that, we forgot our ritual. What was our ritual? The time complexity is big of n going to all the nodes. N is the number of node, and space complexity will be the height or depth, we can call it either d or h, because at given point we will have the maximum whatever the maximum path of a tree has been, and that many number of nodes, which is like the height of a tree, binary tree in this case. So big of h. Okay, now we are done. Okay, bye bye.